Hello everyone. And welcome back once again to another interesting video. In this video we'll discuss the most commonly asked Python interview questions and answers which will help you excel and bag amazing job offers. Each question is accompanied by explanations, tips, and examples to help you prepare thoroughly for your interview. So if you are ready, let's start today's video. Question 1. What is the difference between Python arrays and lists? Answer. In Python, the term array typically refers to the array module provided by the standard library, which offers a more compact way of storing data of the same type. On the other hand, lists refer to the built-in list type, which is more flexible and versatile. Here are the key differences between Python arrays and lists. 1. Data type. Arrays in Python are homogeneous collections of items of the same data type. They can only store elements of a single data type, such as integers or floats. While lists in Python are heterogeneous collections, meaning they can store elements of different data types within the same list. For example, a list can contain integers, strings, and even other lists. 2. Memory efficiency. Arrays are more memory efficient compared to lists because they store data in a contiguous block of memory and require less overhead. This makes them suitable for situations where memory usage is a concern, especially when dealing with large datasets of a single data type. While lists are less memory efficient compared to arrays because they are implemented as dynamic arrays that can resize themselves dynamically. Lists have additional overhead to support their flexibility, such as storing pointers to objects and managing dynamic memory allocation. 3. Performance. Arrays offer faster performance for certain operations, such as element-wise arithmetic operations and array-specific functions. This is because arrays can leverage optimized, low-level operations provided by libraries like NumPy, while lists provide more flexibility and functionality compared to arrays. They support various operations such as appending, inserting, and deleting elements efficiently, but certain operations may be slower compared to arrays due to their dynamic nature. 4. Functionality. The array module provides a basic interface for working with arrays, offering functionalities such as element access, slicing, and basic mathematical operations. However, arrays lack many of the advanced functionalities available in lists. While lists offer a wide range of built-in methods and functionalities for manipulation, iteration, and data processing. They support operations like append, insert, remove, pop, index, sort, reverse, and more, making them highly versatile and suitable for various use cases. 5. Library dependencies. Arrays are part of the Python standard library and do not require any external dependencies. While lists are built into the core of Python and do not rely on any external libraries. In summary, while both arrays and lists serve as data structures for storing collections of items, they differ in terms of data type support, memory efficiency, performance, functionality, and library dependencies. Arrays are suitable for storing homogeneous data efficiently, especially when memory usage is a concern, while lists offer more flexibility and functionality for general-purpose data manipulation. Question 2. How is memory managed in Python? Answer. Memory in Python is managed via reference counting and a garbage collector. Reference counting tracks the number of references to objects, deallocating memory when the count reaches 0. The garbage collector handles cyclic references and unreachable objects. Python also employs memory pooling to optimize allocation for small objects, reusing memory blocks when possible. Additionally, memory optimizations like object reuse, string interning, and sharing immutable objects reduce memory overhead. Overall, Python's memory management system ensures efficient allocation and deallocation of memory while minimizing memory usage through various optimization techniques. Question 3. What are namespaces in Python? Why are they used? Answer. In Python, a namespace is a mapping from names, identifiers, to objects. It serves as a container for storing and organizing the names of variables, functions, classes, and other objects defined within a program. Namespaces provide a way to avoid name conflicts, facilitate modular programming, and enable efficient scope resolution. Namespaces are used for the following purposes. 1. Avoiding name collisions. Namespaces ensure that each name is unique within its scope, preventing conflicts between names used in different parts of the program. 2. Encapsulation and modularity. Namespaces help organize code into logical units, such as modules, classes, and functions, allowing for better encapsulation and modularity. 3. Scope resolution. Namespaces determine the context in which names are looked up and accessed. Python follows the LEGB, local, enclosing, global, built-in, rule to resolve names in nested scopes. 4. Promoting readability and maintainability. By grouping related names together within namespaces, code becomes more organized and easier to understand, enhancing readability and maintainability. Overall, namespaces are essential for managing the naming of entities within a Python program, ensuring clarity, avoiding conflicts, and facilitating modular development practices. They contribute to the clarity, robustness, and scalability of Python codebases. Question 4. What is scope resolution in Python? Answer. Scope resolution in Python refers to the process of determining the scope or context in which a particular name, variable, function, class, etc., is looked up and accessed within a program. Python follows the LEGB rule, which stands for local, enclosing, global, and built-in, to resolve names in nested scopes. Here's an overview of each scope. 1. Local scope. The innermost scope, which includes names defined within the current function or lambda expression. These names are accessible only within the function where they are defined. 2. Enclosing scope. The scope that surrounds the local scope, typically referring to the enclosing functions or lambdas. Names defined in the enclosing scope are accessible to nested functions or lambdas. 3. Global scope. The global scope includes names defined at the top level of a module or script. These names are accessible from anywhere within the module or script. 4. Built-in scope. The outermost scope, which contains names provided by Python's built-in modules and functions. These names are predefined and can be accessed from any part of the program. When a name is referenced in Python, the interpreter searches for it in the following order: local scope, enclosing scope, global scope, and built-in scope. If the name is not found in any of these scopes, a name error is raised. Understanding scope resolution is crucial for writing maintainable and error-free Python code, as it ensures that names are accessed in the correct context and that potential conflicts are avoided. Question 5. What are decorators in Python? Answer. In Python, decorators are a powerful feature that allows you to modify or extend the behavior of functions or methods without directly modifying their code. Decorators are implemented using the @ symbol followed by the name of the decorator function, which is applied to the target function or method. Here's a basic example of a decorator in Python. In this example, my_decorator is a decorator function that takes another function, func, as its argument. Inside my_decorator, a new function called wrapper is defined, which wraps the original function, func. Within wrapper, additional behavior can be added before and after calling the original function. When say_hello is defined with @my_decorator, it is equivalent to say_hello equals my_decorator, say_hello. This means that calls to say_hello will actually invoke the wrapper function, which in turn calls the original say_hello function with additional behavior. Decorators are commonly used for 1. Logging. Adding logging statements before and after function execution. 2. Authentication/authorization. Checking user credentials before executing certain functions. 3. Caching. Storing the results of function calls for later reuse. 4. Timing. Measuring the execution time of functions. 5. Error handling. Wrapping functions with try-except blocks to handle exceptions. Decorators provide a clean and concise way to modify the behavior of functions or methods, making Python code more modular, maintainable, and reusable. They are widely used in frameworks and libraries to add functionality to existing codebases without modifying their core implementation. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.